Hello, hi student. This is Priya, your maths tutor, and once again, I welcome you all on my channel VIDYA. So, in the last session, we have completed exercise 8.3, question number 4 till part 5th. Now, we are going to start part 6. So, in the part 6, we have square root of 1 plus sine A upon 1 minus sine A. We need to prove it equals to secant A plus tan A. Let's again take the left hand side. So in the left hand side, we have 1 plus sine A upon 1 minus sine A. Now we want the we want the answer in terms of secant and tan. How we are going to do this? So for that, we don't want a square root on the right side. So first of all, we'll get rid of the square root. And for that, let's multiply and divide both the numerator and denominator by, let's multiply and divide this expression by 1 plus sine A. So we'll get in the square root 1 plus sine A into 1 plus sine A, 1 plus sine A whole square, and in the denominator A minus B into A plus B, which is A square minus B square, right? Now, we got 1 plus sine A whole square upon 1 minus sine square A is cos square A, right? Now, we can cancel square and square root with each other. So we'll get 1 plus sine A upon cos A, taking the square common and cancelling it with square root. So we are left with not square root. Now we have cancelled it. We are left with only 1 plus sine A upon cos A, which can be written as 1 upon cos A plus sine upon cos A. 1 upon cos is secant and sine upon cos is tan. This is what we want in the right hand side, secant A plus tan A. And we got the same expression. So this is equals to right hand side and as proved. Okay, wonderful. Now let's start the next part, which is the seventh one. Okay, so in the next part, the seventh, we have sine theta minus 2 sine cube theta upon 2 cos cube theta minus cos theta. So let's write the left hand side. Take out the sine common. We are left with 1 minus 2 sine square theta. And in the denominator, if we'll take the cos common, we are left with 2 cos square theta minus 1, right? Now, we know that sine square theta plus cos square theta is 1. So, instead of 1, we'll substitute its value. So, we got sine theta upon cos theta into sine square theta plus cos square theta minus 2 sine square theta. And in the denominator, we got 2 cos square theta minus sine square theta plus cos square theta, right? Now, this sine theta upon cos theta is equals to tan theta. And now, sine square theta minus 2 sine square theta. We'll write a cos square theta first of all, as it is positive. Now, sine square theta minus 2 sine square theta is minus sine square theta. And in the denominator, we have 2 cos square theta minus, let's take out the, open the bracket. So we'll get minus sine square theta minus cos square theta, right? So we got tan theta into cos square theta minus sine square theta. And in the denominator, 2 cos square theta minus cos square theta is cos square theta minus sine square theta. Same term will cancel out each other. So we are left with only tan theta, which is equal to right hand side. Hence proved. Okay, I hope it is clear. Wonderful. Now let's start the seventh part. So in the seventh one, we have sine A plus cosecant A whole square plus cos A plus secant A whole square is equals to 7 plus tan square A plus cot square A. So first of all, let's open the brackets. So A plus B whole square will apply the identity, which is equals to, let's take the left hand side, which is sine A plus cosecant A whole square plus cos A plus secant A whole square, right? Now A plus B whole square is A square plus B square plus 2AB. A plus B whole square here on the right side, A square plus B square plus 2AB, right? Now sine square plus cos square is equals to 1. So 1 plus 2 sine A cos A. And here in the, oh sorry, it was cosecant, not cos. Sorry, my bad. Let me correct myself. So here it was cosecant square A and cosecant A, right? Now, this sine square A plus cos square A, this will be equals to 1. We'll take it in one bracket and plus cosecant square A plus secant square A plus 2 sine A into cosecant A. Cosecant A can be written as 1 upon sine A and here plus 2 cos A into secant A. This secant A can be written as 1 upon cos A, right? So this cos and cos will get cancelled, sine and sine will get cancelled. So we have sine square theta plus cos square theta, which is 1 plus cosecant square theta plus cot square theta. So we will substitute a value here and this 2 plus 2 will become 4. Now cosecant square theta is equals to 1 plus cot square theta, as we want the answer in terms of tan and cot. So we know that cosecant square theta is equals to 1 plus cot square theta and secant square theta is equals to 1 plus tan square theta plus this 4. So we'll add it. Now 4 plus 1 plus 1 plus 1, which is 7. 4 plus 3 is 7 plus cot square A plus tan square A. So we got 7 plus cot square A plus tan square A, which is equals to right hand side. Hence proved. Is it clear? Wonderful. So first of all, what we have done here, we have just applied the identity A plus B whole square in both the terms. We have opened it. So sine square A plus cosecant square A is sine square A plus cosecant square A plus 2 sine A cosecant A. We got this term. Then, and the next one we have cos A plus secant A, which is equals to cosecant square cos square A plus secant square A plus 2 cos A secant A. Now, this sine square A plus cos square A is equals to 1. So we have taken it in one bracket. Now this cosecant square A plus secant square A plus 2 sine A cosecant A. This cosecant can be written as 1 upon sine. So that sine and sine will get cancelled out. And herein also 2 cos A into secant A. Secant A can be written as 1 upon cos A, where cos and cos will get cancelled out. So we have 1. Now we want the answer in terms of tan and cot. We have the answer in terms of cos, secant and secant. So we'll convert cosecant into cot and secant into tan. So cosecant square theta is equals to 1 plus cot square theta. and secant square theta is equals to 1 plus tan square theta. Now 1 plus 1 plus 1 3 plus 4 7 plus cot square A plus tan square A, which is equals to right hand side. Hence proved. I hope it is clear to everyone. Wonderful. So now we are left with the last two parts. So we'll discuss the next two parts in the next session. So for that, stay tuned. Bye-bye. Have a nice day.